What's up, everybody? How you doing? I am here to teach you some computer science slash mathematics. I'd say it's more mathematics. I'm going to teach you how to convert binary to decimal, and that's base 2 to base 10, unsigned binary to base 10 values. So I broke it down in 3 steps to make it ASAP, as simple as possible. So, first step. Assign a decimal number to the binary place value. And let me get my marker out here, show you how to do that. We'll say we'll have five place values for the binary number. And for binary, you can only use 0 and 1. So we'll pick a random order of 0 and 1s for a random number. We'll see how it comes out. That look good? Okay, so we're supposed to assign a decimal number to every one of these binary place values. So what you do is you start from the right side, and it'll be 2 to the 0 power, and then the next place value will be 2 to the first, and then the next will be 2 to the second. So
people that come to Las Vegas, they want to do powder, cocaine.
And it's a little confusing if you leave it with just the exponents like that, so I'm just going to convert it into what it actually is in base 10. So this is 1, 2, 4, 8. So those place values will have a multiple of these numbers. They'll have a multiple of these values. And this brings us to our second step. Multiply the binary with the decimal by the decimal value. So we take the binary value and we multiply it by the decimal value. So 0 times 1 is going to be 0. So that's step 1 right here, and we're moving on to step 2. Okay, so 1 times 2 is 2. 1 times 4, 4, 1 times 8, 8. Okay. I guess my signs are falling down. Okay, so we have some decimal numbers for each place value. But what do we do with those decimal numbers for the binary place values? Not very hard. This is where step 3 comes in. We'll put it right here. That's good. Okay, what we do now is we just add them up. There you go. So the extra 0 over here isn't really necessary, but in computer science it probably is, because there's a set width of values that are always going to be sent through the system. So that 0 would be technically sent through the circuits. but 14 is going to be represented the same way, whether 0 is there or not. Well, not exactly the same way, but the same decimal number, whether the 0 is there or not. So we'll do another example. We'll move on to another binary number. We'll do it in the same way, but I'll go a little bit faster. Okay.
All the way up to doctors, lawyers, stockbrokers. Everybody has money to spend when they come out here, and they spend it with me. I'll get a group of...
Would you like to do an 8 place values? Too much? 5? 6? We'll do 8.
I take out the worry for them, and I go get the drugs for them from, I do it with an assistant with, and that knows that,
So this is our binary number. We're going to convert it. Our first step. Do you remember what it is? Okay.
If I was about to 8 ball of cocaine, that would be 3.5 grams of cocaine, I would get it for 200, and I would resell it to my clients for 300. I make about a couple $1,000 one night, and I go a couple thousand the next night. That's what keeps on Las Vegas running is the drugs, because drugs are going to keep people.
Okay, so we got step 1 there, and now we want to find out which multiple of those decimal numbers that we're going to end up with, and it's really only 2 or 1, but with other base systems, the multiple can be a lot more numbers. There can be a lot more variety in the multiple, but we'll just move on to the next step here. Number 2, multiply binary with the decimal number by the decimal number. 0 times 1 is 0.
We had a tip a couple months ago about someone selling ecstasy cocaine. He lives just off the strip in a high-rise tower. He's a clubhouse promoter, gets a man to pass the lines, and then when they need party favors,
So this
they have a coke, ecstasy, whatever they want to party with, he takes care of them.
I do believe it affirmative was done for the CIA.
You following?
The,
Multiply those numbers, 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 those numbers. And here are our products from all of those multiplications. Now we do step 3. 28, 12, 14, 51, 30, 42, 142. I guess so. I hope that's right. 12, 14 plus 128. Yeah. 142. So unsigned. Not too complicated. 8 minutes in. I think I explained it pretty well. You know, use the 1, 2, 3 system. As simple as possible. Keep it simple. Keep it simple, stupid. Binary isn't too hard, so you should be able to do it. Alright, I'm out.